right, welcome everybody to the premiere episode of the Artificial Intelligence live stream. It is on April 1st. This is not an April Fool's joke. We are really doing this. We've had lots of conversations in both the Web3 and the non-Web3 game development live streams. And it was sort of a running joke from the beginning, honestly, that we wouldn't talk about AI all the time. But then, Oscar, what's our ratio? Have we been tracking metrics on this? What's the percentage of the time that we don't talk about AI? It might be 0%. I think we basically mentioned AI.
It's been successful about 2% of the time, but AI seems to be coming up over and over and over in the conversation. I'm not sure why.
So it keeps coming up. It's as if AI is a real thing that's changing the world in significant ways, and it keeps affecting the conversation. In fact, on Thursday, when we do our normal game development live stream at 1 p.m. Eastern, it's going to be two AI gaming startups, one that's doing like an AI dungeon master called Wanderheart, and another one that's doing a vibe coding platform for kids called Nilo. So we're just talking about AI all the time. So what it led to is we should actually do a series that's just on artificial intelligence and also not be constrained to gaming. So that's what we're doing. And you've joined us here on April 1st. Nope, not a April Fool's joke. We are really going to talk about AI every week at 3 p.m. Eastern on Tuesdays. And let's get started. So my name is Jon Radoff. I'm the CEO of a company called Beamable. We build gaming infrastructure, and I just love to talk about AI and game development and blockchain and all these big trends that are changing the world. And I'm so pleased to be joined today by my friend Tejas Kulkarni. Tejas, why don't you give yourself a brief introduction here?
Yeah, well, thanks for having me. Wonderful to meet everyone here, and thank you, John and Oscar. Yeah, John, I've known for quite some time. It's really fun to be here. So so my background is definitely I come from AI, neural nets. Did my schooling from MIT here, back in the days, and that was really the time, almost a decade ago, that I started thinking about what would it mean to have computer software basically recreate the world, right? Both the fantasy world as well as real world. And then now I think, gaming, I've been playing text-based MUDs for, more than a decade. I think I was very, very interested in that. And that really led us to eventually build CSM, and what CSM is doing is the goal is to really create a 3D assistant. I think, in the same way that AI coding is helping people be very good coders, and I think it's gone really far just right within the last 1 year. And what our hope is that we would be able to help people who are creating 3D assets, worlds, definitely for gaming applications, but also real world products and things like that, simulations, which is slightly kind of more longer term, to make them more productive and easy to create those worlds.
How do you categorize yourself, Tejas? Is it vibe coding? Is it world building? What is this?
Yeah, I think, definitely, I think one of the earliest kind of reasons for me to be, the earliest bets, I guess, when we were starting, for me, was there were two different threads. One is AI coding, which nobody really expected it to be, this good. It's probably the most successful application of generative models. Which is kind of upside down, right? You would have expected the cups and the chairs to be first, but it happened to be the other way around. So you have AI coding on the one side, which is like vibe coding games, and then you have the asset thing on the other side, and they're all meeting together now. So I think coding is, you could argue, it's much further ahead, not in terms of creating a full world, but really kind of making a huge impact. I think nobody knows how far it can go, really. Even with the current models, if chained together properly. So I think, but the content piece, the gooiness of the real world, right? The dragon kind of moving around in some way, or the chair looking the way it should be with all the PBR materials. So that's really the art aspect of things, right? So I think if you can have both of these things, then your regular artist can become a superhuman artist, and someone who doesn't even know anything about art can actually start dabbling in it. So I think the way I see what we are doing is AI coding is happening independent of us, and I think we are building the 3D generative models that are going to kind of interface with that and really truly open up the vibe revolution in many ways on both sides.
So Tejas, let's maybe develop that idea a little bit more. So this is the first AI live stream that I've done, and awesome attendance already. We already got a couple hundred people in the live audience here listening to this, and I imagine it's like other streams I've done recently, a few 100,000 views in replay. Not everyone may be familiar with even the idea of the difference between training a model or creating a foundation model versus a lot of other things that they see in AI that are using somebody else's model.
Yeah.
My understanding is at CSM, you guys are training new foundation models for 3D graphics. That's right?
Yeah, and I think
Why do you need to do that?
Yeah, it was more out of like a need, necessity than kind of we wanted to do it. And there's a lot more open source components now. You can mix and match, train more, and things like that. So the problem is, if you look at image, video, text, code, a lot of those things are way more mature because the amount of training data on the internet is at least like many orders of magnitude larger, right? If you try to buy the entire Shutterstock's library of 3D assets, you'd get less than 1 million assets, much less than that, and but hundreds of millions, billions of images, right? So the big challenge for 3D is that you can't really just scrape the internet, I think, for data. Like it's not possible to do it at scale. It's data efficient.
So unlike 2D, we're not riding on the coattails of millions and millions of photographers and 2D artists who've
you
content.
can't. And I think and if it's also reflects how humans actually learn the task, right? By the time you're 18 years old, 20 years old, and you start doing some of the design work, you've probably seen billions of image pairs, right, from the real world. But how many meshes has a 3D artist seen? Like barely any, kind of compared to that. And that's true of also what machines are seeing, right? So fundamentally, you have to have a data efficient way to learn these systems, and some of the architectures are data efficient. They had to be. So the models are basically the models underwent kind of a two-phased kind of step change. Pretty much in 2023, 24, half of 24, the models were actually taking some of the image diffusion models and doing this method called distillation, score distillation, which basically meant you take a large image model, a text-to-image model, and then you essentially ask it to render many different views of it, and then you backpropagate that information into some sort of a 3D representation, right? Gaussian splat or a NURF or 3D mesh, whatever. And then that gave you pretty good textures, but it didn't really give you good geometry. So those kind of fell out of favor in some sense, although there are some good ideas there. Might come back in some form or the other, for sure. But then they became 3D native. So a lot of the current models are actually reflecting a lot of the workflows that people have, like geometry, polygons, PBRs, and things like that. Like, so there are multiple models now stacked on top of each other to get to the final representation. So that's really what a 3D foundation model is at the asset level. And then once you have an asset, then comes the piece of animation, right? So you could directly animate it with skeletal-based methods. That's kind of one thing you can do. You can also do things like, and which is getting easier by literally as early as last week. I think GPT-4o has been a breakthrough. I think it will get unraveled in the next few weeks. Where even if I have a random concept art image of a new character or a prop, I think now we have image tools that can both the Gemini native image generation, GPT-4o. I think you can actually like reimagine that in T poses and ask for different parts and do these type of things, which is what you actually need to get to like usable assets. So you have kind of you have this kind of combination approach to get a foundation model for the asset level, and then you have the foundation models for code, right, which interfaces with the asset layer. So yeah, so that's kind of foundation model layer.
Okay. So there's a lot to unpack there, and so I'm going to try to unpack. But first, before we do that, we're already up to about 300 live audience here. I want to remind everyone there's a reason we do this as a live show as opposed to a recorded show that I did that actually did a recorded show on this subject in the past, but it was 2 or 3 years ago. We do everything live now so that you, the audience, have an opportunity to come in, ask questions, actually participate and be part of this conversation. So if you're here and listening, you have a really unique opportunity to engage live with Tejas, who's a leader in this field. He's CEO of Common Sense Machines, which is building foundation models and a whole tool chain around 3D graphics. And Tejas is the real deal. He is a PhD from MIT. So like he's the guy you want to talk to and ask all your questions from. So please take advantage of this opportunity to ask your questions about graphics and AI in general. I think there's a lot of ground we can potentially cover. And if you even want to join the show live, that can happen as well. So Oscar's watching all the channels. We're transmitting to Facebook, LinkedIn, YouTube, Twitch, X. We're on all these places. Wherever you are, post comments. We'll share those comments. But if you want to join live, let Oscar know. We'll bring you in and you could ask your questions live and on the air too. So that's a possibility. If you have something about AI that you just want to talk about, these shows are here to be dynamic conversations. So Tejas, going back to maybe unpacking a little bit. So we ran right through some of the things that came before what you were describing, 3D native models. And I just want to spend a little bit of time on that again, because I think a lot of people want to just understand what's happening better. You ran right through Gaussian splats. So my understanding of the way Gaussian splats work is you can use photographs, multiple photographs of a scene, and it's sort of like reverse ray tracing. So we look at those images and we figure out something about what the point cloud of light that could have generated that would have been if you take those photographs and back into the ray trace, essentially. I think that's basically the understanding. Now, a nice thing about Gaussian splats is, again, it can depend on photographs, and we've got lots of videos that have multiple scenes and things like that. So you can start to get this sort of 3D-ish immersive experience that comes from that. But I think what you're saying is it's almost like pretend 3D. It's not really 3D in terms of how we think about 3D immersive experiences today. Can we spend a little bit more time on that? What are the shortcomings of something like a Gaussian splat, even though I think the results are pretty cool looking for certain things?
Yeah, I mean, what Oscar is showing on screen, I mean, so that bench, for example, looks very realistic, right? It's like, it's hard to get that in the polygon space, right? To really get that level of realism. And like what you were saying is like, it's really kind of the intensity of light, luminance shining from a particular point in 3D space. So that way you can represent a lot of thin structures, different materials. But really, doing physics with this is hard, right?
Right.
So it's hard to get interactions right. It's hard to get. We still haven't figured out how to get like full relighting and mixing it with existing assets in a dynamic way. Although you could imagine Unreal or something could with Nanite and some of the other type of engines in the future will have some pretty seamless integrations with these. The problem with these right now is that it's very good for visualization. Basically, if you're doing product visualization, I think this is really useful. Although it's still not at, it still hasn't gone in production. Like your Amazon website, you don't yet see Gaussian splats, right, of products yet. And I think the reason for that is because we have talked to many of those people. I think early on we were trying to see if this is a use case we want to go after. What happened there is if you can't control every single pixel of your Louis Vuitton bag or whatever, right? Then people get scared of that, right? So editability is really hard with this. So I think one of the big challenges for these approaches is going to be how do you make it very editable? Because artists have a whole pipeline of doing polygons and PBR maps and shaders and all of these things. Kind of in a splat land, it's kind of an implicit representation of Gaussians with some parameters that are very hard to manipulate. But I believe that there will be kind of just like how you can control images now, there will be tools to control these type of representations, and it will be a new medium basically, right? A new game engine someday in the future. and it might get combined. There's also ways to combine that with meshes.
Mhm.
So there are ways to kind of mix and match these things in principle.
Can I ask
Okay, so
a question?
yeah.
Is Gaussian splatting the same thing as photogrammetry, where like someone takes a camera and they, I've seen those two different things, but they seem to be fundamentally different on some level.
Yeah, the photogrammetry is more like mesh land, right? So, and the reason why that doesn't look realistic is it's very hard to get meshes to look like the real world, because the real world is not a mesh, right? In the real world is kind of a reflection of light. And if you actually, it's really cool where Gaussian splats come from. If you trace the history of Gaussian splats all the way back to where the first paper was, it comes from Kajia's work in computer graphics. But if you look at what Kajia is citing, he's citing work of light scattering in Saturn rings. So they're trying to model how light looks like when on Saturn's rings, and reflections
Yeah.
and reflections come. So if you want to model phenomena like that, then you actually need to have a very general approach, right? It's just kind of a model of light fundamentally, right? In a more general sense. But with photogrammetry, you're first modeling the polygons, and then you're wrapping textures on top. So that's the basic difference of both of these methods.
The other difference too is that photogrammetry, you're really scanning the entire environment and you're building the whole 3D scene from all of those data points, as opposed to Gaussian splat. You can use a sparse number of inputs. You don't actually need all of the photos showing every possible view of the object. You're building the point cloud of light essentially from the few photos that you have. And you can still kind of walk around it and see it from all these points of view. So it's neat. It can always correct me if I'm wrong about anything, Tejas, but that's my understanding about the way Gaussian splats work. You wouldn't have to scan every aspect of the photo, although I think more is better. I've done some, and when I had a lot of photos, it very much improved the result. But the short,
yeah.
so
And
the
one more cool thing
shortcoming.
about that, oh,
Yeah, go
sorry.
ahead. No,
No,
please
just one
continue.
more cool thing about the Gaussian splat is that you can actually have a neural network predict a splat from a single image or text also.
Interesting.
You
So
can't
you
do
could,
that.
yeah, so
Yeah.
sparse could be one input and it'll do its best. Interesting. But then the issue with Gaussian splats are, well, I guess we can start with where they're useful. And you're pointing out if you want to do something like be able to see a 3D-ish representation of an object, like product catalog views, look at the Louis Vuitton bag, as you were saying, that see it from any point of view to improve the chance that someone might buy that object. That's a use case. There's probably a lot of interesting use cases in just static video as well, because you could do fly-throughs of scenes and various renderings that are not interactive.
Yeah.
But if we get into the world of 3D, that's where it gets harder, because that's where physics becomes the issue that I think you're pointing out earlier. So with real 3D scenes where we built 3D worlds with 3D meshes present in them and various objects, we've got not only the presentation of light, but we've got things like what happens when these objects collide with each other? How do they respond to each other? If you're a video game, how do you handle things like collision detection and bullets and all these things that come out? So like there's a lot of issues with a immersive interactive 3D environment that would be, maybe not impossible to solve, but maybe hard to solve using Gaussian splats as the rendering system. Is that
That's right.
kind of a way to think of it?
Yeah, I think I agree with. Yeah, I mean, I think so. It's just that they look very realistic, and I think if we can bring their realism to and kind of solve some of the issues you kind of just highlighted, then we have best of both worlds. There is a pathway. I think there is a pathway to, and in all the cool thing is that in a lot of the work that happens in predicting meshes, for example, in these foundation models and 3D foundation models, splats are actually are used in the intermediate parts of the pipeline as loss functions and as training targets. So it's very incredibly useful to do that actually. So even if you're not going to use the splat is very helpful basically to
So
get to them.
we've got actually a great question, unfortunately, from anonymous LinkedIn user, probably someone who's a couple of degrees separated from me, so I don't know their names. But thank you for the question, asking about how you build an AR world. I think he's asking, how would you use AI to generate objects that would be useful in AR? Are there different considerations for something in AR versus just a completely virtualized world like an
Yeah,
MMO or an online game?
I think like splats are really useful for AR, right? Because if I want to take
Hmm.
like real world machinery, shiny things, machine parts for education, for cars, for jet engines, whatever, right? I mean, I think, things that are quite complex and people use ARs for a lot of those education training applications.
Hmm.
Maybe it's for like, go more like Pokemon style kind of games that are out there in the real world. I think for AR, actually, it's closer to visualization, right? Because you're not doing like deep interaction. A lot of the interaction is also with the real world. But some of the AR applications that people seem to be using a lot more, the appearance matters a lot, right? So it depends on what you're trying to build. If you're building a game, then it really, I mean, then you have to think of it as a game engine, right? Just a mesh-based
Right.
representation. But I think AR is probably good for like AR and splats can work pretty well with each other, I feel.
Right, because you're saying in AR, it's not the same level of interactivity that we would have in a game where you're got objects bouncing into each other and collision detection issues and
Yeah,
physics and gravitational forces and all these things that you have to deal with within a immersive game environment or a simulation for that matter. You
yeah.
were touching on simulation earlier, but in AR, a lot of the time you're projecting images into the real world and you're kind of referencing an educational application. You might want to just walk around the jet engine and see what it looks like.
Yeah, like one of the most magical AR experiences I had. I mean, unfortunately, the Apple device is not no like it's not being done so much. But I mean, I do have one. And then if you've seen kind of the experience where the dinosaur they're fighting
Oh
with,
yeah,
and they come outside, right?
yeah.
So there are splats that are also four-dimensional splats. So they're like movies, right?
Hmm.
So I think to generate things like that, you want to be in the splat land. So that's a really good kind of it's going to come back, I think, at some point when we have good enough glasses and things like that.
So earlier we were talking about the challenges of 3D. So let's bring it back to 3D. We've talked a
Yeah,
little bit about the advantages of having something 3D native. And by 3D native, you mean built from geometry describing objects in the environment where you can apply physics rules to these objects. You talked about the absence of enough training data to do this
yeah,
at scale. What else is hard about this? Like, is
yeah,
that it,
yeah.
or could we solve it if we had a billion 3D models we could just download and train a
So yeah,
model?
no, it turns out I think you don't need that much. Like I've been surprised how data efficient they are.
Hmm.
So when I first started, I mean, this many years ago, it just didn't work. But we're just kind of fiddling around and more or less trying to get these models to do something. But I think for the same data sets, the models are actually getting better and better. So what I mean by that is, if you kind of send in an input image, and if you basically show, inspect kind of the normal maps and the geometry maps, right? Some of the more recent architectures, without changing the data set, they're astronomically better, right? Which is, I think, which was not something that I expected. So I don't think we're going to be data bound, which is good news.
Hmm.
And
Hmm.
because there isn't enough, right, at
Hmm.
all, and I don't think we need that.
Hmm.
And there is existence proof that the human brain has figured this out. So I think it all kind of adds up. I think from first principles, and then so that's kind of like the basic core premise. And I think the second thing is from a more AI standpoint, there's still a lot of talk, but now that has kind of gone down with vibe coding revolution. So there was a whole feeling, I think, for the last 2 years that meshes are just a bad idea. You know, everything is going to be a video model. Everything's going to be like Sora that you kind of go in, input, just press kind of keyboard actions, mouse actions. You're going to be in a Sora world. I think that's going to happen. That's going to be a new form of interactive media. Like, you have papers from DeepMind like Genie 2 that are incredible. I think that's
Hmm.
just a new world model. I think that is going to be built. The problem with that world model is that there is no coding. So a real world model actually also needs to have program synthesis because that's where a lot of persistent state and just all the things that we have from programming. I think, if kind of God was building a simulator, I think it'd definitely be a programmer to kind of express reality in the fullest extent. But I think 2 years ago, meshes was like a bad idea from an AI standpoint, like a deep learning community. And although, like, they were trying to, nobody of my, in my friends group, they were like not interested in meshes. It's kind of like, that's kind of like not the end-to-end deep learning path. You should just predict pixels and videos and put in actions, you'll get a game engine out, right? That was kind of the feeling, because I don't think most people expected program synthesis to even work. I think, there was no kind of there was no belief. I mean, even I was like a staunch believer in these neurosymbolic systems, but I didn't kind of predict it would happen so quickly at all. So there was this kind of just surprise, I think, of how fast it moves. And so I think, we don't need that much data to learn 3D, and program synthesis has worked just by training on massive corpuses of text and code and stuff like this. So I feel like I don't think we need a miracle now. I think the miracles are kind of, I think we have like these two miracles, I guess, kind of colliding in some sense. So now it's going to be, I think there's a straight shot from here.
I'm trying to get a super clear understanding of something you just said, though. Are you saying that you think we'll eventually move past meshes and everything will just be image, like the models will be so smart that they'll figure?
I don't think, I think there will be like, they will all kind of mix with each other, but I think there's something really powerful about code as a representation, right?
Okay.
In a world model, because you can do anything. I mean, in principle, right? It's like massive compositionality. You get a lot, and I think it just wasn't clear that if that would even be possible. So I think the mesh-based route for building open worlds with AI was just kind of a bad idea. I think from the get-go, because of like there was just kind of people didn't believe it would be possible, right? But I think with all this vibe gaming stuff happening, the AI coding revolution taking off, 3D generative models working better than what they used to, I think it's gonna work. And I think then you'll have these video models that will also be used as implicit as kind of blocks, pillars that can get you dynamic assets and 4D assets, and a lot of kind of 4D interactions, right? That are hard to capture with code. Just kind of a monkey kind of taking a basketball, and there's a giraffe who's like standing there, and they're both playing kind of ball, right? I think how do you kind of simulate that with code? It's hard to do that. So for that, you just need to have good visual priors, right? Which will come from these image models, video models.
Okay, so you are saying, though, that you see a future where we kind of skip these intermediate representations in 3D and just skip to video output based on ingesting parts of a scene and then telling you what the result is based on some kind of prompt?
I think the eventual
thing
is so in the AGI land, ultimately, I don't believe that to be true, because I think AGI will figure out that it's actually efficient to recompile the game into how humans have figured out, but maybe even better, right? So there are some good ideas, I think, that the community has figured out over the last 2-3 decades.
Because a mesh is basically code. If you think of it, like a mesh is code, it's a way of representing an object in probably one of the most minimalist forms possible. You've got the geometry defined, and then you can apply a texture to it, and you can do all these things with it, as opposed to trying to video render it. Seems like that's a very data intensive process to go from a neural net with all of the possibility space that represents, and then infer out of it video outputs.
No, it's true. I mean, what you're asking, I agree with you. I mean, I think what you're asking is probably the biggest open question in AI. I mean, this is like, I think this is the AGI, ASI problem. Like, if you want to build a world model, how should you build it? Right? That is the only, I think, interesting and kind of the biggest open problem left, I think, in AI, I think, at this point. Right? And there are two opinions, I think. One opinion would say, no, it will just be the predictions of a neural network, which will be pixels, and actions will come in. And I think that will happen. I don't know if there's a limit to how far that can go. And then, but I think if that's going to happen, then I also believe the neural net is also going to predict code that recompiles the predictions of that video model into something more kind of shorter program lengths, right? So I think it's ultimately it's going to do what it's looking like right now, but better, I think. So we'll have to see, I think.
Les is commenting here from YouTube that he's a mesher artist and it sounds depressing to him. Should he be depressed?
No, I think it's actually not at all. I actually was so no, you shouldn't be. I think, and I'll give you like a clear reason for this. Like the video model, people will do the video things, right? I think that will be more like VFX movie making. I think it'll be like an exploration tool. Maybe even large movies will be created by that. But I think there's something fundamental about the kind of things you're doing, which is connected to coding, which is what John was also saying. I think you'll be fine from the principles of Kolmogorov complexity. I think there are things that will just kind of remain in the computational substrates of what the kind of things you're looking at. I mean, last March or April, I actually felt like how you're feeling now, right? Which is AI coding was taking off, and I'm definitely a programmer, I think, at heart, and I just started feeling a bit depressed initially because I was like, programming is not going to be the same anymore. It's kind of very different now. What do I do with my life? I like company building, but I actually like programming more, like as an art form for no reason. And I think what I've realized is now it works so well, and I don't program the same way that I do, but the amount of code I've written just in the last 2 months is like more than the last few years. And I think I feel much better. I'm not scared at all. I think the scope of the projects that you're going to do, every project will look like GTA 6, right? Plus whatever. So I think the level of our quality of our work will just be shifted up, and I think we would all be doing like massive projects, and I think people who don't know anything, they will be creating today's games and today's experiences. But I think the people who are professionals, who have spent a lot of their lifeblood, sweat and tears on this, I think they would create monumental projects. I really do believe this.
You think people will scale out the kinds of things that the individual person is able to do, as opposed to like a net decrease in human labor? I think that's what you just said.
I think so. Otherwise, it will start becoming uninteresting, and it'll just fizzle out from human culture, right? Anyways,
like you mentioned Kolmogorov. You mentioned Kolmogorov complexity, and I love the fact that we're throwing out all the big terms here. I think that's what we want this AI stream to be known about. So we're talking about the basic, like what is the minimal level of complexity for a computer program or object, and I guess to apply that term to some of the things we've talked about, like Kolmogorov complexity for a Gaussian splat system seems like much higher than many basic 3D model, 3D mesh-driven things, right? So you're saying that things probably will, even if it starts out as these video systems that are very complex and they're able to do all the inference, that you get this perfectly aesthetically consistent image and it interacts with gravity and physics and all these other things that we care about in the scene. The problem is that it won't be compressed enough. And the AGI, should we have one, would be like, okay, now let's figure out the simplification model for that, and you end up with something that probably is not too far off from a mesh system or kind of a 3D based on 3D primitives and physics rules that we've used we've learned that from the real world and kind of taught computers how to interact with things that are relatively similar to the real world. Although, truth be told, a lot of graphics in games, for example, have no similarity to the real world. They're like a collection of mathematical hacks, shader graph programming and stuff, which we've come up with because they're a lot faster than doing ray tracing. So that's an interesting thing to think about at the same time as well.
That's kind of aligns with what you're saying, and I think another kind of way to think about what you're saying from a brain tooling and brain perspective is, if you think of splats or video models, that's kind of the content of your dreams and your brain, right? If you're a creator, if you close your eyes, like the brain actually, there's a cool phenomena where you can actually measure people. You can give someone a cube or whatever, right, and ask someone to do mental rotations.
Okay.
And if
I'm
you
doing it.
actually, and you can, and it turns out that you can't do like from A to B. You actually, the brain does it in a like a video, basically internal video, and you can measure this with fMRI, right? So your brain is kind of rendering these pixely things in your head. But if you had to, as a designer, go and use tools and Blender and other things, then you'd have to kind of translate that imagination. So a lot of, I think, it's kind of these two systems, right? One is the GUI imagination, which is not symbolic, and then you have tool use to compress that down even further into something that is kind of manageable, right? So we are probably in the first phase of AI, I think, for the most part, and then the second phase would come with like computer tool use, MCP servers, and code, and all these type of things. Kind of distilling all of that knowledge into something reusable, reprogrammable, all of that stuff.
I'm caught on this thing you were just saying about our brain and dreams, because before you said that, I think what I heard you just say is we basically have a little bit of a video buffer with multiple frames in our brain that our brain can render against for doing things like imagining a 3D rotation. Before that, I was thinking about my dreams, and I was thinking, I'm not sure my brain actually does video. I'm not even sure really what's happening in dreams.
Yeah.
I had assumed it was sort of like a symbolic representation that feels like video because it's the best my brain can kind of come up with. But is it really? It seems
Yeah.
like it's a lot simpler than that. But maybe I'm wrong about that, because you're saying we actually have a bit of a rendering capability in the brain as
I
well.
think you're right. I mean, I think we definitely, like, if I have to plan a trip to go to Japan, like, I definitely, you're right that I don't render out a whole kind of sequence. I mean, that would be quite a feat. But I think like if you lucid dream, right? I think this is a repeatable experiment. I've definitely tried this because I was interested in. This was my main interest in the 3D reconstruction topic. Is I actually used to get these temporal lobe seizures, and I have like heightened amounts of lucid dreams because of this. Like many years ago, now they've kind of quieted down. So I think the brain can render pixels, but it doesn't do that unless it really has to. But it does have it. I think it's sometimes when you have had a super vivid dream, right? It's very realistic. So it can do it if it has to do it. But I think most of the time, your brain will fry. It takes up a lot more computation.
So let's dig into a little bit of what you're doing at Common Sense Machines. So we've been talking about all of the problems. We gave the barest thumbnail of what you're doing at Common Sense Machines, but bring us current. Like, what's the problem you're solving right now? If I go to Common Sense Machines, your website, what can I do? And tell us anything that's coming next.
Yeah, so I think so fundamentally, like if you go on our X, I think a cool video we could start with is if you go on our X channel, there's a video that's kind of at the top entry, just a few days old, like here. Yeah, this is a cool one to start with. So I think um, so we have various different workflows, but a one that actually makes sense for a lot of people is if I'm trying to create characters, right, for your game. I'm trying to create props. Oftentimes, for it to be useful, I think you want to break it up into all the constituent parts, right? So that you can rig the system. You can actually put interactions on the hammer and something else. So you want all of this to be built as fast as possible. So this is like a 15-minute workflow that I actually did. I'm not an artist, so it's not like the perfect job on this, but it's a starting point for you to then take this forward in whatever it is that you're doing. And the way it works is there are different ways to input things into your system, right? So you could input your concept art, front back things, sketches. You could input kind of images. In this case, I think GPT-4o, when it got released, I think it's phenomenal at taking single pictures and generating individual parts from that. So you could kind of input it like a random picture of anything, really, something that you want in your game, and you could ask it, regenerate this, keep everything as the same, but put all the parts nicely on a sheet, right? Because I want to reassemble them. So that was the prompt that I did, and then it gave me that image on the bottom left, right? And then from there, our tools can take that and generate what you're seeing on the right, which is it's an unedited output, right? That I just kind of put things together. You can kind of disassemble it, and you get PBR assets and meshes and things like that. So now you can take this asset and rig it and do kind of your game logic on top of this, right? So what we are building is like both at the part level, at the asset level, but also at the scene level, tools to actually make these type of processes faster and easier.
Mm-hmm. Super impressive that you break it down to the components like that, and you're able to recombine.
Yeah, because that's I think and if you go down, I think if you kind of scroll down a little bit, a bit more, like that's one more example, right? Where you can also do there are some manual steps involved in going from the right, but I think you want to reduce that as much as you can. But you can also get all the components in the right T poses, right? If you follow the right workflows, so you can rig them, get the ground plane to be what it's expected to be, and you can keep building your world right from asset onwards, right?
And Tejas, just so we're clear, so everyone's clear on what we're looking at here. So the left-hand side is an illustration that was the input.
Yes.
And the right hand is the 3D model generation that came from that.
Yeah.
Now,
yeah.
Does it understand that those two characters in the scene are independent characters, or is it building just a big 3D mesh that's kind of all thrown together? Like, what's happening? How much does it understand about the logic of this representation?
Yeah, so you have to guide the work. So there are some manual workflows right now. It's not fully automated, right? It's because even in the parts spacing that I told you about, sometimes you only want the belt. Sometimes you want the belt to be kind of just merged into the clothing. So in this case, they're actually all independent. Like the three characters are independent. But I think we have different workflows for that. So you could either do everything as merged. You could do like a parts asset-based workflow. So depending on which workflow route you go down, you kind of follow certain steps, and then you end up kind of at the right level of decomposition. But the scene assembly, disassembly, part assembly is not a fully solved problem. I think it's we are starting to now go beyond from single asset to parts of single assets to this kind of worlds, right? But if you scroll down a little bit, you'll see like if you go down a bit more, a bit more. A bit more.
And everybody, just go to Common Sense Machines X page. Go look at this stuff yourself, because their demos are super cool, and I think you'll learn a lot.
Yeah, keep going down. I think just a little bit more, a little bit more. I want to get to the scene level. I think if you keep scrolling, I think in a second you might find it. Keep scrolling. Keep scrolling. Oh yeah, no, this one. Yeah. So so this is also a scene that's created using our tools. It's a very complex scene. I mean, I think this is kind of the grand challenge, right? So if you expand that, you'll see why that's complicated. There's a lot going on here. Like there's hundreds of assets. All these assets, by the way, are from our product, right? So even the text and everything, we have tools to like get that right? Like you can do quick touch-ups to, if the logo is messed up, you can fix that, and things like that. But I think the important thing here is that the placement here was not automated. I think we don't have technology yet to get to this level of scene. I think once you get to this level of scene, we have basically a 3D AGI in existence. I think then we would be able to do pretty much a lot. I think unimaginable things. I think so. We're trying to work towards that. We are kind of at the small kind of mini world, a few parts, few things level, but the goal is to get to this level essentially.
Now, I just saw something fall off the shelf there. So we got it, because before I saw that thing fall off the shelf, I was also thinking, what I want is all of those distinct objects in the 3D scene to have their own representation, so that now the car can crash into the shop from behind and everything knocks over and it follows normal real world physics that we're used to. So how close are we to that? Is that the 3D AGI?
Yeah, I mean, that I think there will be two steps to that. So I think the hardest step for that is to have this agentic scene builder, right? That can create this type of representation. Everything is its own components. That is the harder part, because once you have done that, then putting mass and gravity and other things on these assets is going to be relatively possible. I think it's not going to be solved, but it's going to be possible with at some basic level. It will be possible for gaming applications with visual LLMs, right? You could say, ask the thing, oh, what's the mass of this Lay's chip, and stuff like this, and you can probably get like pretty far with that. And then I think a step after that is if basically a dragon comes there and kind of flaps their wings and stuff like that. Then how do you model the interaction of the dragon wings, right? Which is slightly different than modeling physics, because that's about biochemical reactions inside the dragon. So that's where I think these models will have to be tied to video models in a general way. So that hasn't happened right now. People are doing rig-based systems, but they will evolve into more like video diffusion-based systems.
Well, ultimately, you're even dealing with things like fluid dynamics there, because I'm thinking of the dragon's wings, you're moving air. So what is the result of air turbulence and air currents, and how does that affect a scene and the objects in the scene according to things like their air resistance properties and their weight and stuff like that. So we've got a whole bunch of questions coming in from the online audience. So let's take a moment to look at some of these. So Les asked an interesting question around rigging. You mentioned a little while ago when we were looking at the 3D character that you would rig it yourself. What about auto rigging as just yet another step that would jump into this?
I think I think especially the way image models are like automatically placing assets in the right orientations now from any input. It's not a fully solved problem, but it's last 1 week, it's dramatically better. So I would say auto rigging is very much kind of possible now, especially if you're doing vibe games and stuff, right? I think it's like, someone should start trying that. I think ASAP. Like, if I had a little bit more time, I think the tools are there now. I think, you could create a lot of different embodiments, like bodies, and, start doing auto rigging. There's a paper RigNet, which came out some time ago. And then there are some other startups and companies who are also kind of specializing in that type of technology. And I think we have been wanting to add that. It's just that, the models were not, we were not getting good orientations all the time, right? But now some of that is much better.
And another question here coming in from LinkedIn, the question is, what do you recommend for people who are not coders, but want to be able to do work like this? I think one answer is the URL is csm.ai. Like you're not targeting coders who are programming this stuff. It's a user interface with prompting and things like that. And you supply an image and it works out the 3D models.
I mean, I think that's kind of like there was an earlier user, one of your dialed in person asked the question, like, should I be concerned as an artist? I think as a programmer, I should be more concerned, honestly, because I think the whole trend of what's happening here is that even the vibe gaming stuff that you're seeing is that if you're a creator and an artist, I think there's going to be these SaaS tools. Oh yes, as mesh, the mesh artist. I mean, you should not be depressed. I think you should actually be happy, because you can probably create now the content much better than anyone. Like I would, for example, but you would also be able to actually do the programming bit a lot better now, right? So I think you now are kind of in control of where the future of this interactive medium goes. I think you don't need like people like me essentially in the same way, right? That you need it. I think it will. I mean, programmers are going to be of course needed. I think but you can now do a lot of the things that you would have asked someone to do and spend a lot of time. So I think this is going to be purely additive. We're in this kind of local minimum of subculture kind of feeling. When something new comes, it's kind of scary, but I believe we are going to pass that stage soon.
Les asked this question here, and he's saying, well, does it save us time, but then we make less income overall? I'd love to hear your comment. I don't buy that business case. I think here's the other way to look at it, Liz. I think the value of your time has the potential to go up significantly with all of these AI tools. Like I already find that happening for myself, even just using things like ChatGPT, deep research, like how much I'm able to like learn about a topic, even though I don't necessarily consider ChatGPT, for example, to be the ultimate teacher and I have to go and like look into things myself. Deep research is a button I press now to give me a roadmap of learning a whole bunch of stuff. And then I go off and I learn sort of the next level down on my own rather than depend on it. But it's an accelerant and it saves me a lot of time. And I feel like that paradigm plays out across a whole lot of things. So if the value of your time goes up, then economically speaking, that should translate into even greater income.
Yeah, no, I agree with John. And yeah, I mean, definitely you can email me at tk@csm.ai. Definitely email, like, would love to hear from many of you. And just to kind of add one small thing to what John said. I think if you look at YouTube, right? YouTube had like many people, like I can shoot a video, but that doesn't mean that I can shoot a good video. And the entire economy of YouTube has transformed so many people's lives. I think you want gaming and 3D to be there, right? I think it's such a small economy right now. You want all of us to get to a point where we are at least at the YouTube economy level, right? So and I think then taste matters, right? Taste, creative direction. I think these are the types of things that are going to matter a lot, because if everyone can generate anything at some level of realism, I think, or engagement, then that's going to be normalized. So if you actually have creativity of any sorts, I think you're going to be able to do a lot with that.
So we've got
Something
over.
that comes. Oh, sorry.
Go ahead, Oscar. Ask your question.
John. No, I apologize. Yeah, John, we're up to over 1,030 people joining us, but I guess I run a small, it's not small, AI generated art group. It's about 200,000 members now. And I deal with about 500 to 1,000 submissions per day. I have to vet them because, user generated content. But the argument comes up a lot. Is AI generated art? And my contention is absolutely. I don't go and grind up, like flowers to make paint anymore. The idea, the creativity, that still comes from a source and inspiration. I don't think it's fair to claim that I drew this pixel by pixel, but I can also say that this does not exist without my hand on it, in some form or another. As someone who is, neck deep in this argument, I'm sure, but is also exploring it technically as well as creatively. What is your opinion? Is AI generated art?
Yeah, no, that's a great question. So I actually play like harmonium, which is like accordion, right? I really like playing that with a group of people, and like that's one of my favorite things to do outside of AI. And so really, I'm like an artist at heart, right? Not very good, but I think I really understand, like, when people say, if you want to paint, like, have the Ghibli image, it's not about the image itself; it's the process of actually doing that, right? Like, the physical things, and the life experiences that go on underneath all of that. So I think that will never go away. I mean, I think I totally hear what the whole problem is all about. I think it makes sense, but my feeling on this is that this is inevitable, right? I think there's like a new medium, it's forming, and it's an inevitable medium. um, uh, I think it will just kind of lift us up as people who practice different forms of arts, to kind of do to find the next level of niche, right? Whatever that is. And I think there's a lot to do there. So I do kind of hear all the concerns about, like, it's just different art, right? Being in front of a computer and spending many hours, for many programmers, that's art form, right? I think literally, like, I mean, it's kind of the meditative space of being in front of a computer for like hours on end, I think, and producing like this beautiful piece of thing, a digital piece of thing. So I think that has been art for many people, right? But for some other people, like, playing an instrument in person is better than Suno and other things, right? But I think that's okay. I mean, I think we're just gonna have, there's just more art now. I think there's just more of it, essentially. So I don't think the concerns are going to go down. There will be some cultural kind of back and forth on this, because they are different things, right, at the end of the day. But they're just different. I think they don't conflict with each other. I think they are just different. And if you are doing that for your ego's reason, right? If I was playing harmonium for myself, like how good I am, right? Versus because I love doing it, right? I think it's for the love that you're doing the art, right? So why are you concerned about this? If you're loving it for your own art, then just love it for your own sake. Like, then that's the true art. So I feel like there's a lot of egos also at play here, right? When we are looking at all of
absolutely. Yeah, I've written about this topic a lot myself. When generative art a few years ago started getting popular, I wrote this article called "The Work of Art in the Age of Generative AI," and I just talked about that. And it's sort of like, what is art anyway? Like, it's one of these things that people have just questioned, and the problem is everybody has their own definition of art. I like Rick Rubin. Rick Rubin wrote this book on creativity that everybody should check out if you're really interested in creativity. And he's like, well, what is art? It's really just an agreement, like that people agree that something gets to be declared art. Like, that's the easiest way to say that something is art. The thing that you put up on your wall in a frame because you got it in an art gallery, and other people visit your house and they nod and say, yes, that is art. Now it's art just by social agreement. So anything that could fit anything, including things that are generated by computers. It also brings up this question of what is creativity. And to me, creativity, sometimes people think of it as this mystic, like almost inspiration comes from the void into your brain. But I think creativity is simpler than that. I think it's a search through like a big solution set, and creativity is just being good at the search. If you're really good at the search, you're able to come up with better solutions faster, but you're really just sort of probing a whole massively multivariable space until you come up with things that are useful. That's how I think of it. I don't think creativity is mystical. I think it's actually just mostly mathematical. It's
Yeah,
combinatorial.
that's, I mean, I think, yeah. Although I mean, I definitely, like, there's a major portion of me that agrees with you, like maybe, but there's a 10% side of me which is like, it's like like being an artist is like a spiritual form. It's almost like going to the monastery, right? And kind of shedding some identity that you had, and creating a new one, something like this, right? I think in some sense. So, but no, I think what you're saying, even there, it makes sense, right? I mean, if if it's all about like shedding your identity to create a new one, and the art form is an expression to do that, right? And the output of the art form is almost like the that kind of trace of memories that you leave as you kind of walk around in life. I think if you're doing it with that intention, like the pure art, there's not much for you to worry about, because it's not the content of what you create is going to be like, you wouldn't want to create what AI creates, right?
Yes.
Because it would be kind of boring as an artist. So you would want to kind of go beyond that in some sense.
Yeah, or the musical example given, like I play piano.
Yeah.
There's millions and millions of people who play piano at an expert level, way beyond what I'm going to do in my life. But I can play stuff competently that I choose to play, and I just do it because I enjoy it, and I enjoy the act of like channeling that art through myself and reinterpreting it and making it in real time. So that joy is not taken away either by the fact that a computer might be able to do that in the future. Actually, computers already do. If you just want computers to play music for you, like pretty much that's a solved problem for decades now, that computers could generate synthesized music quite competently, right? Now we're having them create things as well, or do things improvisationally, so people start to get a little bit upset about it. But that doesn't take away my own personal experience of expression any more than the fact that there's commercial musicians out there who make tons and tons of money aren't taking away from the fact that I can also enjoy the act of creativity or expression through music. But I guess it all comes down, the controversial area is just there's a whole long list of people out there who earn a living from it, and when people feel like earning a living is threatened, then they get upset about it. And it's not so much about whether it's really human art, it's whether I get to make a living doing my art in the same way that I always have. And clearly big questions remaining there.
No, it's true. Yeah.
Tejas, this has been a really fun conversation. I would love to have you back anytime, frankly. You have so many ideas. You've got really deep background in all of this stuff. And this was episode 1 on April 1st, not an April Fool's joke. We covered a lot of things. And I hope everyone will go back and check out the X feed from Common Sense Machines, or just go to csm.ai. You'll see a lot of really compelling examples there of how you can use 3D generative art from things like InImage. It's very, very cool stuff. So check that out and check out our next program. So tomorrow on Wednesday morning, we've got a conversation on Web3 gaming again. And then on Thursday, we've got the AI in gaming discussion that we're going to have with Wanderhart and Nilo. So I hope you'll come back for both of those. We're up to 3 programs a week now. And we're doing this because there's been so much interest in it. We've got, at the end of the hour here, we're hitting the peak number of 1,230 people. If we stuck around talking to Tejas for another hour, we would probably get to 2,000 or something. But we're keeping these shows tight. It's going to be a 1-hour program. We're going to deliver a lot of value during that time. And there were some great questions as well. So Tejas, let me thank you for being here. And until next time, thanks to the audience for taking out part of your day to be with us.
No, thank you so much for listening to me and this wonderful opportunity to connect with so many people. Thank you. Thank you.
Thank you, Tejas. And thank you, Oscar, for keeping us on track here. All right. Until next time, everybody, take care.
Thank you. Bye.